Hello guys, this is the review for the second exam. We start with a compound interest problem. A 25 years old man wants to have $2 million on his account at the age of 70. What amount should he put aside now? You will have the formula sheet. So for this problem, you need a compound interest formula. So we know the future value A, which is 2 million. Then we know the number of years. So he started with 25 years and ends saving with 70. So the number of years T will be 70 minus 25. So 45 years. Compounding is done quarterly. It means M equals 4. The total number of compounding periods will be 4 times 45, 180. Now we can use the formula. 2 millions equals P times 1 plus R over M. So all the end R is 0.0225. 0.0225 divided by 4 raised to the power 180. So let us find the value of this expression on the right. 0.0225 divided by 4. Then we must add 1. Then raise it to the power 180. So we got that 2 millions equals P multiplied by 2.744675,842. We don't need so many numbers, but I don't want to think every time how many digits I need, so I just keep them all. To find P, we must divide by this 2.7 and so on the left and on the right to find P. So I can use the answer key here, 2000 divided by the answer from the previous step. So P is 728, 683.50. On the exam, you will input this in 3 different blanks, so $1,000 and cents separately. Okay, this amount should be put on the account now to get 2 millions in 45 years. The second problem, unpaid balance method. So we start with $405. We need to find the balance at the end of the month, and then we will find the finance charge. To the balance, according to the formula, we must add the finance charge for the previous month, which is found on base of this 405 of last month balance, multiplied by RT. R is 0.25 and T is 1 over 12, so we divide by 12. 4, 5 times 0.25 divided by 12. So approximately 8.438. Then we must add or subtract all the adjustments that are made to the account. So we made a payment. It means we reduce our debt to the bank, so we subtract 220. Then charged 120. We increase the balance, we increase our debt to the bank. It must be added 120. Return something for $40. Subtract 40. The balance is less when we return something, and charge 30, so plus 30. So let us find this balance. So we add 05, subtract 220, add 120, subtract 40, add 30. So the balance at the end of the month is 303.4375. And now we have to find the finance charge for the second time. This is the finance charge that will be charged on the next month, will be added to the balance of the next month. So it is also by the formula PRT. Now P is the balance that we have just found, 303.4375. And RT the same as in the previous step, 0.25, the annual interest rate divided by 12. So we take the answer from the previous step, multiplied by 0.25 and divide by 12. And it is approximately $6.32. You see, we calculate finance charge 2 times, first for the previous month and add it to the balance, and then for this month that will appear on the next month bill. Use the average daily balance method to find the final charge. So the numbers are almost the same or exactly the same. So there will be several variations of the problem. Be careful that they might look similar but still be different. So in the average daily method, we care about every day. So in the previous method, we did not care about the dates of this adjustment. Now we will look for every date, and we will calculate the balance for every day, so to say. So the first balance is $405, and it held for first, second, third, and fourth 4 days. So you must multiply by 4. Second balance, we made a payment, so we subtract 300 and we get $105. And this balance was from 5th to 12th. Here in the middle of the month, we can just subtract 12 minus 5 is 7 days. So to be sure, if you don't know where you can subtract, where you cannot subtract the dates, just list the dates for the whole month, second, third, until we have February 28 days. So, and calculate the number of days for every balance. Okay, so here we have 7. Then we charged 120. So we add 120. It will be $225. This time 18 minus 12, 6 days multiplied by 6. Then we returned 14, subtract 14, 185. This balance was from 18 to 25th. 25 minus 18, 7 days times 7. And then the last balance will be charged 30 plus 30 will be $215. And at the end of the month, you better write at least the dates. It is very important. So this last balance was from February 25th, 25th, 26th, 27th, 28th. 4 days. We multiply by 4. And now we add all these balances together. 105 times 7 plus 225 times 1. Okay, I forgot the very first balance. 405 times 4 plus 105 times 7 plus 225 times 6, 185 times 7 and 215 times 4. So the total is 5860. We must divide this total by the number of days to find the average daily balance. Average daily balance. 5860 divided by 28 days. I use the answer key, divided by 28. It will be approximately 209.286. And then I find the finance charge based on this balance. Finance charge is always P, average daily, RT. This time R is 0.25, but for T we must take 28 over 365. So we care about every day, so we cannot take just 1 over 12. Okay, we must multiply by 0.25, then multiply by 28 divided by 365. So the finance charge will be $4.01. This is the finance charge according to the average daily method. The next problem is ordinary annuity problem. You see here, ordinary annuity. We want to save money, making a regular payment. A monthly payment is 280, and monthly payment is the uppercase R, $280. Annual interest rate is 0.0375, and we know the time T is 10 years. So for this problem, we also need N. N is the M times T. Compounding is done monthly, and the payments and since it is an ordinary annuity, it must be the same period, 12 times a year, 12 times 10, 120 compounding periods in total. And so we substitute this in the formula 280 multiplied by such a long fraction, 1 plus 0.0375 over 12 divided by raised to the power 120 minus 1, don't forget this one, and divided by again 0.0375 over 12. So if you use a small calculator, then first you calculate this number, R, M, but I use decimals, so I can just input this formula, and I will start with R over M, 0.0375 divided by 12. This time it is an exact number, plus 1. Then I raise it to the power 120. Then subtract 1. Then also don't forget to use parentheses on every step. This must be divided by 0.0375 divided by 12. So this is the value of this fraction, and we want to multiply it by the regular payment, 280. So that annuity, the amount of money that will be accumulated on the contract in 10 years will be $40,691.02. Also, you will input it in 3 different blanks on the test. Amortized loan problem made with a table. So please learn how to do it with a table. On the written homework, you have done it with a formula. It gives a little bit different answer, especially when you use the strange formula. So a family bought a new house for $320,000. They decided to pay down payment $80 and finance the rest for 30 years at the interest rate of $12. First, let us find what is the amount of the loan. So the house, $320,000 minus the down payment, $80,000, $240,000. This is the amount of the loan. The table gives the regular payment for 1,000. The regular payment for 240,000 will be this value multiplied by 240. Let us find the payment for 1,000. This loan is taken for 30 years with the interest rate of 12%. 30 years, we are at this column, 12%, this line. So we choose this cell in the table, 10.29. This is the regular payment for 1,000 loan for for 240,000 loan, we must multiply this number 10.29 by 240, and that's all. It will be a regular payment for this loan. 240 times 10.29. The regular payment is $2,469.60. Situation B, suppose they have found the loan with 10% interest rate. So it means that we must find another line in the same table, the line with 10%. So this 8.78 and multiplied by the same 240. So 8.78 is the regular payment for 1,000. For 240,000 will be 240 times 8.78. $2,107.20. Of course, it will be less since the percent is less. And then a couple of problems for chapter 10. An organization has 3 departments, A, B, and C. Apportion 12 representative board seats to these 3 departments. Use Hamilton apportionment method. So for you have 2 ways how to use this method. First, you can use it how we learned in chapter 10.1. Find the percentage of employees in every department multiplied by the number of seats to apportion, but we can do it a little bit quicker with standard divisor, finding the standard divisor. First, we need to find the total population. So we add all employees, all departments. It is 6,201. And then we find the standard divisor by dividing 6201 by the number of representatives to apportion by 12. So the standard divisor is 516.75. Now for every department, we can find the standard quarter. Dividing the population, 2082, by the standard divisor, the same for every department. For A, we got 4.03. We don't need more than 2 digits after the point, but 2 digits are necessary. B, $31.44 divided by the same standard divisor. The quarter will be 6.08. And for C, the standard quarter is 1.89. So first we assign the whole parts for or lower quarter, 4, 6, and 1. Count them together. It is 11. And we want to assign 12. So we have 1 extra. Who will get this extra? We look on fractional parts, 0, 3, 0, 8, and 80. 89 is the greatest one, so the department C gets an extra representative. So the apportionment is 4, 6, and 2. Then consider the situation B. Suppose that there is a fourth department with 2,200 employees. So the new total, we add 2,200 to the total population. It will be 8401. Then, so we do the same steps, but with new numbers. So we find the standard divisor, dividing the total population by the new number to a portion of representatives. So, and okay, it is on the test. It will be written how many seats will be added to the department. So we can use the standard divisor. Actually, divide by the standard divisor 516.75. So approximately 4 seats. So we increase the representative body by 4. So 12 by 4, 16. And now the total population we divide by 16 to get the standard divisor. The standard divisor for this, for the second apportionment, for B, will be 525.625. So, and now we do the same way for every department. Now we have 4. We find the standard quota. For C, it will be 975 divided by standard divisor, 1.86 approximately. For B, it will be 3144 divided by the standard divisor, 5.99. For A, 2082 divided by the standard divisor, it is 3.97. And the last department, D, with 2200, and it gets 4.19. 4.19 standard is the standard quota for D. According to the method, or the Hamilton method, we first apportion the lower quota or the whole part of standard quota. 3, 5, 1, and 4. Let us add them together to find out how many extras do we have. 10 plus 3, 13. The total number to apportion is 16, so we have 3 extras. It can happen, it's still less than 4, the number of departments. So, and these 3 go to the departments with the greatest decimal part. So we have here 97, 99, and 86. Only the last department has 18. So A, B, and C get 1 additional representative, and the apportionment is 4, 6, 2, and 4. So the question is whether we have here the new state paradox that can happen with the Hamilton apportionment method. You can answer that in this situation we don't have, because all departments have the same apportionment 4, 4, 6, 6, 2, 2 as before adding a new department. So no new state paradox in this example. It can be different on the test. So next problem is Huntington-Hill apportionment principle. An organization has 3 departments, complete the missing Huntington-Hill numbers and apportion 9 representative board seats. So first we need to complete the table. You know that in the Huntington-Hill number table, we have in the first line population of state X squared divided by the present number of representative, which is 1. The current number is 1 in the first line, times future number, times 2. In the second line, population squared divided by present number. In the second line, it's 2, and times future number, which is 3. Then, in the third line, population squared divided by 3 times 4, and so on. So for the first empty box, it is the second line, so we must raise the populations to the square, and we take these numbers in thousands. So it is B, so we take 5.644 squared divided by 2 and divided by 3. So 3 is in denominator, it means we must divide by this 3. 5.644 squared, divided by 2. So now I write this in denominator, that's why I write multiplication sign. If you use a normal another calculator, you must understand that you divide by this 3, you must press divide by 3, or you can write 2 times 3 in parentheses and divide by the product 2 times 3. Okay, so this is 5.31. We need only 2 numbers up to the point. The second cell here, the population of C is 1.975 squared divided by 2 divided by 3. It is 0.65. And in the third line, we have population of A, 2082 squared, divided by current number, 3, and future number, 4. (2082) raised to the square divided by 3 and 4. So, and here was the dot. So it is 0.36. And now we want to apportion 9 representatives. We know that the first 3 are already apportioned. When we start this apportionment, every department has already 1. So first we give 1 to every department, A, B, C, the first 3 seats. Then the next seat goes to the department with the greatest Huntington-Hill number. First, we'll look on the first line, 2, 15, and 1. 15 is the greatest one, the greatest number, so the fourth representative goes to B. and we cross out this number. Then we compare numbers that are upmost in every cell, in every column: 2.17, 5.31, and 1.95. 5 is still the greatest number, so the fifth goes also to B. And we cross out this number. Then we compare numbers 2.17, 2.65, and 1.95. 2.65 is still the greatest number. Sixth is also B. Then we compare 217, 159, 195. 217 is the greatest. The next representative goes to A. And now we compare 0.72, 159, and 195. Now 195 is the greatest number. So the next representative goes to C. So the next number that we'll compare will be 0.65, 159, and 0.72. The greatest number is 159, so the next goes to B. So we have apportioned 9 seats, and this is the order in which they have to be apportioned. The next problem is about average constituencies of two states. We will compare them to find the state which is more poorly represented. We consider here Arkansas and Florida. So Arkansas has the population 3,018,000 and 4 representatives. So the average constituency of Arkansas is 318 divided by 4, 754.5. Florida has population 21,478 and 27 representatives. So the average constituency will be 21,478 divided by 27, 795.48 approximately. So I think the problem will ask you to round to the whole number, which will be approximately 755 and 795. What state is more poorly represented? So poorly represented, so more people are represented by one person. So, and it is Florida. 795 is greater than 755. So one representative represents great number of people. What is the absolute unfairness of the apportionment? Absolute unfairness is just the difference. 795 minus 755, and it will be 40. Absolute unfairness. Relative unfairness is absolute unfairness divided by the smaller constituency by 755. 40 divided by 755 is approximately 0, 5, and 3. So round to 3 digits after the point. And the last problem Here is the example, and we will consider this one. Assume that house costs $280. The down payment is 15%, and you must pay 2.5% in points. And the other closing costs $3,200. So, what is the deposit on this house? We must find 15% of 180,000. 180 must be multiplied by 15% in decimal form. Multiplied by 0.15, $27,000. So the loan consists of the remaining dollars. So 180,000 minus 27,000. This is the loan that you take from the bank. 153,000. You pay 2.5% in points. So this 2.5% are taken from the remaining loan. So you take 153,000 and multiply by 2.5% in decimal form, 0.025. It is $3,825. So, and what is the sum? The total sum that you pay at the end at closing. It is the down payment, 27,000 plus the points, 3,825, and plus this extra cost, 3,200. So the signing for your mortgage, you must pay 34,025%. Okay. So when solving the exam, please read carefully what the problem asks from you. So don't skip any steps, any points, and read carefully. At the end, take a photo of your shown work. So this 10 problem also costs 10 points. So the total is 100 points for the exam. So, and upload your work. So you will have a link where you can combine if you have several pages, combine them into the one PDF, because Proctora doesn't allow several file uploads. You have only one attempt to upload your shown work file. If you fail to do this, you can use the second attempt immediately afterward. Okay, good luck on the exam.